So, package just received from America. This is something I pledged for on Kickstarter. So, let's open it up. It is made of titanium. What I'm really interested on this, do you know how to open a box? What I'm really interested about on this is the surface finish. Like I'm always just obsessed with the surface finish on, you know, anything titanium, metal, that kind of thing. Mainly titanium. So, whoa, cool box. Look at that. Blows my packaging away, that's for sure. Trans Metals. That's a funky logo. Good. So we got a cloth, a white glove, that's weird. It's only got 4 fingers. What kind of freak do they think I am? Oh wait a minute, no. The thumb one's inside out. Now I don't know if I need this, but they've given it to me, so I'm a bit of foam on top, and then this. Oh, that's heavy. I mean, if you've not figured it out already, I mean, I design and make stuff in titanium. This is called Trans Metals. The title of this YouTube video, by the time you watch it, will probably give it away, but I mean, it's kind of obvious what's in there, right? I'm gonna put it on this, just to... Ooh, that has got a phenomenal finish. I'm impressed, I have to say it. I am impressed. I can see why you need the glove. It's not perfect, there's some sticky stuff from... They've managed to get some sticky stuff from the sellotape onto here. Now obviously you can't see yourself, but you can see the camera. That is a damn fine finish. $200 that cost me, $200 US. I like it. I really do like that. Well, colour me impressed. I am impressed. They definitely delivered on this project. In saying that, they also made quite a bit of money as well, because I know what it costs to make this, you know, like it doesn't cost $200, that's for sure. Give you a better look at it actually. Bring you closer. It is a true mirror polish. It's not like perfect mirror, because titanium, it's unavoidable, it's gonna have like, it's got a particular shade. Like I can see I'm a slightly different colour in here, but it's close enough. Okay, so let's do some jet engine stuff. Well, miniature jet engine stuff. What I've got here is the manual. This manual covers a few different engines. I've got kind of a middle of the range one, size wise. And so that's it there, it's the K100G, which means it's got 100 newtons of thrust, which is around about 10 kilograms, which is around about 22 pounds for you imperial folks. So what I'm gonna do first of all is I'm gonna basically, actually, I should tell you what I'm doing. I'm going to design on the computer a mount so that we can sort of mount the jet engine on the workbench and, you know, just to test it out. So I'm going to design that today. I definitely won't be cutting it today, don't have time for that. So what I'm going to do is show you me designing the mount. The first thing I need to do is get roughly this shape into the 3D program, and then that way I know where the limits are, how long it is, how wide it is, where the mounts are, and then I can design the mount around that. That's the way I approach it anyway. I've got the computer screen here, but you're really not going to see it very well if I just film the screen. Luckily, the wonders of technology, I can do a screen capture and splice that in to this video. So that's what I'm going to do. Right, let's do it. about halfway through just now, nearly done. But you can see there's a lot of lines. Like you draw 10 times as many lines at least than you end up with. You know, you've kind of got to sort of build a framework and then sort of build up what you need to build and then strip it away again. Maybe that's just the way I do it, because I'm kind of self-taught with this, so I don't know if there's standard practice, but that's the way that makes sense to me. Now you could be wondering why I copied it. Well, usually, and I've not done it so much with this, is I'm always copying and pasting. As I progress with the drawing, I copy and paste, and so I can see a trail of how I've gotten to where I want to get. So especially if I find out a problem down the line, I can go back and sort of kind of retrace my steps, and I don't have to start all over again, and you know, that kind of thing. So that's why I'm doing that. I'm about to strip away the turbine part of it and just leave the turbine mount itself, and I just want to be able to make sure, you know, if I need to check for tolerances or fit, that I can sort of put the engine back in again. So hence leaving a copy sort of to the side for afterwards, just in case. So that's pretty much the drawing done. What I'll do now is I'll use the software. We've got further software that we use, and that basically converts it for the water jet cutter itself, and it'll convert it into a file. What it will show you is the path that the water jet cutter will take as it cuts out the piece of titanium. So those pinkish reddish lines, they're basically where what's called the kerf. That's the width of the cut when the water jet cutter cuts through the metal or whatever you're cutting through, and that's typically around 0.8 millimeters wide. It varies from 0.7 to 0.9, and you can get a lot narrower if you put on a narrow nozzle, but I won't go into that here. So that's pretty much it. Like, that's it designed and ready to go on the water jet cutter. Right, I think that is it for today. Hope you enjoyed that. Right, catch you tomorrow.